Dear students, very good morning to all. In this class, we will discuss to chapter number 9, differential calculus, limits and continuity. Already we have learned first two exercises how the function have limits or does not exist. In the second exercise, using some properties, that is limit x approaches a, x power n minus a power n divided by x minus a, which is equal to n into a power n minus 1. Okay. In the next exercise, we will discuss two topics, two important one, that is infinite limits and limits at infinity, limits of rational functions and sandwich theorem. Okay, now discuss about infinite limits. Okay, consider the function the function f of x equal to here x square into x minus 3 divided by x plus 7. Okay, this is the function. Okay, this is the function. Here apply limit, that is x approaches x naught, that is some point. Here some value is minus 7 means x approaches x naught, that is minus 7 means here limit x approaches x naught, that is minus 7. Okay, minus 7 f of x, which is equal to limit x approaches minus 7 x square into x minus 3 divided by x plus 7. Here replace x equal to minus 7 into the function, that is minus 7 square is 49, minus 7 minus 3 is minus 10, minus 7 plus 7 is 0. Denominator goes to 0 means, that is the function approaches to infinity. Okay, the function approaches to infinity, that is x approaches x naught, that is minus 7. Then f of x approaches infinity. Okay, f of x approaches infinity. This is called the vertical asymptotus. Okay, vertical asymptotus. Okay, we conclude one result. X approaches some result, some values, then f of x approaches plus or minus infinity means that is the vertical asymptotus, that is called the infinite limits. Okay, that is called the infinite limits. In the structure, in the different form of structure, that is x approaches x naught means at particular point means f of x approaches plus or minus infinity. Okay, both sides. Then x approaches x naught minus means minus represent as direction from left to right. Okay, f of x approaches plus or minus infinity, as x approaches x naught plus means x approaches x naught from the right side. Okay, right hand side. Then f of x approaches plus or minus infinity. Okay, this is called the infinite limits. Okay, this is called the infinite limits. Okay, next discuss about limits at infinity. Next discuss about limits at infinity. Okay, consider the function f of x. Okay, f of x, any one functions. Okay, f of x be the function. Okay, here either side means both sides, left approaches, right approaches. Okay, limits at infinity means here x approaches x naught at plus infinity, otherwise minus infinity. Okay, that is plus or minus infinity. Limits at infinity means x approaches x naught, that is plus or minus infinity. Okay, here limit x approaches x naught, that is x naught is plus infinity means, okay, plus infinity means apply to the limit of function exits some limits. Okay, exits some limits. In another one case, that is limit x approaches minus infinity, that is another one end. Replace x equal to minus infinity into the function, that is f of x, which is equal to limit exits. Okay, limit exits means both are equal, means therefore the function, that is y equal to f of x equal to some limit. The function have some limit, that is L. Here y equal to L is the horizontal asymptotus. Okay, is the horizontal asymptotus. Okay, here we conclude one result. Limits at infinity means x approaches both n plus infinity or minus infinity. The function have limit means, that is the limits at infinity at horizontal asymptotus y equal to L. Okay, or f of x equal to L. Okay, next discuss about limits of rational functions. Next discuss about limits at infinity of rational functions. Okay, here let r of x be the rational functions. Okay, be the rational functions. That is r of x, which is equal to, in the structure of p of x divided by q of x. Okay, p of x divided by q of x. This is the rational functions. Okay, limits at infinity means, x approaches x naught, that is plus or minus infinity. Okay, plus or minus infinity, any one. Okay, at either end. Okay, here we are classified to three cases. Okay, classified to three cases. Case number one, here comparing the degree of p of x and q of x. Okay, degree of p of x greater than degree of q of x. Okay, then the relation between p of x and q of x is degree of p of x greater than degree of q of x, means satisfies these conditions, means the function, that is limit x approaches infinity, rational function, that is r of x equal to p of x divided by q of x, that is p of x divided by q of x. P of x divided by q of x, the function approaches to plus infinity or minus infinity. Okay, plus infinity or minus infinity. Okay, next case 2, here again comparing degree of p of x and q of x. Okay, degree of p of x less than degree of q of x. Okay, degree of q of x. This is the relation between p of x and q of x. Okay, satisfies these conditions, means then the resultant, that is limit x approaches plus or minus infinity p of x divided by q of x, that is the function approaches to 0. Okay, the function approaches to, the value is 0. Okay, next discuss about case 3. Degree of p of x which is equal to degree of q of x. That is, degree of p of x equal to degree of q of x means 1 equal to 1, 2 equal to 2, 3 equal to 3. Both sides are same. Okay. Then the procedure is limit x approaches infinity, p of x divided by q of x, which is equal to highest degree coefficient of the highest degree of p of x. Okay, coefficient of highest degree of x in p of x. Okay, of x in p of x. Okay, then the denominator coefficient of highest degree. Okay, highest degree of x in q of x. This is the procedure to find the limit at infinity. Both degree, that is degree of p of x equal to degree of q of x, both are equal means, then the procedure coefficient of highest degree of x in numerator, that is p of x divided by coefficient of highest degree of x in q of x. Okay, next discuss about to sandwich theorem. Next discuss about sandwich theorem. Consider three functions. Okay, limit x approaches x naught. This is the curve y equal to h of x, that is one functions. Y equal to g of x is another one functions. Okay, y equal to f of x lies between h of x and g of x. Okay, h of x and g of x. If f comma g comma h are functions such that open interval I, okay, open interval I contained in capital R from capital R, it means real numbers from real numbers. Okay, such that g of x, the function g of x less than or equal to f of x less than or equal to h of x for all x in deleted neighborhood of x naught. Okay, deleted neighborhood of x naught contained if both end, that is limit x approaches x naught g of x equal to some limit, that is L. Okay, and another one n limit x approaches x naught h of x equal to some limit, that is L. Both end are equal means, okay, both end are equal, have same unique real number means, then the function f of x have same limit. Okay, f of x have same limit. This is called the sandwich theorem. Okay, next discuss about some problems using this concept. Exercise 9.3, question number 1, option A. Find the left and right limits of the function f of x equal to x square minus 4 divided by x square plus 4x plus 4 into x plus 3 at x approaches minus 2. Okay, solution. Given function, given f of x equal to x square minus 4 divided by x square plus 4x plus 4 into x plus 3. Given function we can simplify, that is in the numerator x squared minus 4 can be written as 2 squared, that is a squared minus b squared, which can be written as a plus b into a minus b. Okay, then the denominator x squared plus 4x plus 4, which can be written as x plus 2 the whole square. Okay, that is the factor product twice, x plus 2 into x plus 2 into x plus 3 here, then the factor x plus 2 are cancelled. Finally we get x minus 2 divided by x plus 2 into x plus 3, x plus 2 into x plus 3. This is the given function. Okay, to find left limit and right limit. Okay, to find f of x approaches some x naught, that is minus 2, left limit means minus, okay, and to find another one side, that is f of minus 2 plus means right limit, okay. Now to find limit x approaches minus 2, minus means x approaches minus 2 from left side, okay, from left side. The given function is x minus 2 divided by x plus 2 into x plus 3, okay. Here replace x equal to minus 2 into the function. Minus 2 is, in the numerator have minus 4, then the denominator have minus 2 plus 2 is 0, minus 2 plus 3 is 1. 0 into anything 0, then the denominator 0 means, then the resultant goes to infinity, okay. Now identify infinity means plus infinity or minus infinity. How to identify the function approaches plus infinity or minus infinity means, we take deleted neighborhood point of minus 2 from left side, okay, from left side, substitute the value, the function approaches plus infinity, okay. Students, check to it how to identify the function approaches plus infinity or minus infinity means, we take deleted neighborhood point of minus 2 from left side, simplify to the functions, okay, simplify to the functions approaches plus infinity, okay. To find right limit, that is limit x approaches minus 2 plus the function x minus 2 divided by x plus 2 into x plus 3. Here replace x equal to minus 2 into the function. Numerator have minus 2 is minus 4, then the denominator have minus 2 plus 2 is 0, minus 2 plus 3 is 1, which is equal to infinity. Here how to identify the function approaches plus infinity or minus infinity means, we take one point, that is deleted neighborhood point, plus means take from right side, okay, neighborhood point take right side, substitute the functions, the value approaches to minus infinity, okay. Next subdivision 2, that is B option. Find the left and right limits of the function f of x equal to tan x at x approaches x naught, some limit is pi by 2, okay. Here solution, given function f of x equal to tan x as x approaches pi by 2, okay. To find left and right limit, okay, to find left limit, that is x approaches by 2 minus means from left side, okay, and to find another one value f of pi by 2 plus means x approaches pi by 2 from right hand side, okay. Here the given curve, that is f of x equal to tan x, we know that the curve tan x, here x, y, x dash, y dash, this is the origin, okay. Here this is the pi by 2, this is pi 3 by 2, okay. In left hand side minus pi by 2 minus pi minus 3 by 2, okay. The given function is not defined at pi by 2, 3 by 2, minus pi by 2, minus 3 by 2, okay. Similarly to the up to 2n plus 1 into pi by 2, okay. Here we know that the curve of tan x means tan pi by 2 tan 0 0, tan minus by by 2 minus infinity. Okay, here another one, pi by 2 to 3 by 2 means like as similar. Okay, minus 3 by 2 to minus by 2 means like this type. Okay, here to find left limit and right limit, approaches by way to from left means here limit x approaches pi by 2 minus f of x is tan x. Okay, f of x is tan x. Here replace x equal to pi by 2. Okay, tan pi by 2 minus means approaches left side. Okay, from left side. Here consider the graph. X approaches by 2 from left side means the curve goes to, okay, x approaches by 2 in the left side. This is the left side. Okay, this is the right side. Okay, this is the right side, this is left side. Left side approaches pi by 2 means the curve is upward. Okay, the curve is upward means equal to plus infinity. Okay, equal to plus infinity. Limit x approaches pi by 2 plus tan x, which is equal to, replace x equal to pi by 2 into the function, that is tan pi by 2. Here consider the graph, refer the graph. X approaches pi by 2 from right side means the curve is downward. Okay, the curve is downward means approaches minus infinity. Okay, approaches minus infinity. Okay, evaluate limit x approaches x naught, that is 3, x square minus 9 divided by x square into x square minus 6x plus 9. Solution: given function f of x, given the function f of x which is equal to x square minus 9 divided by x square into x square minus 6x plus 9. Further, given function we can simplify, that is x square minus 9 can be written as 3 square. In the structure is a square minus b square, which can be written as a plus b into a minus b, that is x plus 3 into x minus 3 divided by x square into here x square minus 6x plus 9, which can be written as x minus 3 the whole square. Okay, x minus 3 the whole square, that is the factor multiplied twice. X minus 3 whole square is x minus 3 into x minus 3. Okay, here the factor x minus 3 are cancelled. Finally we get the given function, that is f of x equal to x plus 3 divided by x square into x minus 3. Okay, to find the limit at x approaches 3, that is limit x approaches 3 f of x, that is x plus 3 divided by x square into x minus 3. Okay, x square into x minus 3. Here replace x equal to 3 into the function. Here plus means right approaches, from right approaches. Okay, here x, replace x equal to 3 into the function, that is 3 plus 3 is 6 divided by 3 squared is 9 into 3 minus 3 is 0. 9 into 0, anything 0 into anything is 0, that is 6 divided by 0. Anything divided by 0 is like as infinity. Okay, like as infinity. Okay, here limit x approaches 3 plus f of x approaches plus infinity or minus infinity. How to identify the sign plus or minus? We take deleted neighborhood point at 3 from right side. Okay, from right side. For example, let x equal to 3.1. Okay, 3.1. Substitute the function have some value, that is positive means the function approaches plus infinity. Okay, suppose limit x approaches 3 minus means the function x plus 3 divided by x squared into x minus 3. Replace x equal to 3 into the function. 3 plus 3 is 6 divided by 3 squared is 9 into 3 minus 3 is 0, that is infinity. Here the function have plus infinity or minus infinity means we take neighborhood point at 3. From left side means we take x equal to 2.9. Substitute the function have negative sign means, okay, negative sign means the function approaches minus infinity. Okay, fourth question, limit x approaches infinity x cube plus x divided by x power 4 minus 3 x square plus 1. Listen students, here the function have rational function, okay, that is p of x divided by q of x. Listen, limit x approaches infinity, okay, limit x approaches infinity, that is limits at infinity, okay, limits at infinity, okay, limits at infinity. Here using the concept that is degree of p of x, okay, this is p of x, this is q of x, okay, q of x, degree of p of x which is equal to highest degree, okay, coefficient of highest degree in x of p of x. Here x power 1, x power 3, highest degree is x power 3, coefficient of highest degree of x in p of x, that is coefficient is 1, that is 1, okay, sorry, degree of p of x is 3, okay, degree of p of x is 3. Then degree of q of x, okay, q of x, degree of q of x is, this is the highest degree, okay, that is 4. Then the relation between degree of p of x and q of x is degree of q of x greater than degree of p of x, okay, that is, which can be say in another format, degree of p of x less than degree of q of x. Therefore the given function limit x approaches infinity p of x, that is x cube plus x divided by q of x, x power 4 minus 3x square plus 1, which is equal to 0, okay, which is equal to 0. Therefore the function have the limit is 0, okay. Next question number 6, limit x approaches infinity means limits at infinity, okay, limits at infinity, okay, infinity. Here this is p of x, this is q of x, okay, q of x, degree of p of x which is equal to highest degree is 3. Then the degree of p of q of x, degree of q of x, okay, which is equal to 3. Both are equal means what is the procedure to find limit of the given function, that is highest degree of coefficient of highest degree of x in p of x divided by coefficient of highest degree of x in q of x, that is limit x approaches infinity 1 plus x minus 3x cube divided by 1 plus x square plus 3x power 3, which is equal to, this is the procedure to find the limit of the given function, coefficient of highest degree, okay, highest degree of x in p of x, okay, x in p of x divided by coefficient of highest degree of x in q of x, okay, in q of x, which is equal to highest degree is 3, coefficient is minus 3, divided by denominator is plus 3, minus 3 divided by plus 3, which is equal to minus 1. Therefore, the given function limit x approaches infinity 1 plus x minus 3x power 3 divided by 1 plus x square plus 3x power 3, which is equal to minus 1. Okay. Question number 8. Show that third subdivision limit n approaches infinity. Given series is 1 divided by 1 into 2 plus 1 divided by 2 into 3 plus and so on plus 1 divided by n into n plus 1, which is equal to 1. Okay. Here we take left hand side to prove RHS. Okay. Proof. We take LHS. We take LHS, that is limit n approaches infinity 1 divided by 1 into 2, 1 into 2. Don't consider to 1.2. Okay, here this is read as 1 into 2. Okay, plus 1 divided by 2 into 3 plus and so on plus 1 divided by n into n plus 1. Okay, which is equal to here limit n approaches infinity summation n equal to 1 to n. Okay, 1 to n. Then the last term, that is 1 divided by n into n plus 1. Okay, n into n plus 1. Here 1 divided by n into n plus 1 using partial fraction. Using partial fraction. Using partial fraction. Which can be written as limit n approaches infinity summation n equal to 1 to n 1 divided by n minus 1 divided by n plus 1. Okay, using partial fraction, then the term 1 divided by n into n plus 1, which can be written as 1 divided by n minus 1 divided by n plus 1. Okay, here replace n equal to 1 to n into the function, that is limit n approaches infinity, replace n equal to 1 up to n into the function, that is 1 divided by 1 minus 1 divided by 1 plus 1 is 2. Okay, substitute n equal to 2, 1 divided by 2, 1 divided by 2 minus 1 divided by 2 plus 1 is 3. Okay, plus substitute n equal to 3, 1 divided by 3 minus 1 divided by 3 plus 1 is 4 plus and so on. Substitute n equal to previous of last term, that is n minus 1, 1 divided by n minus 1 minus 1 divided by n minus 1 plus 1. Okay, plus last term, replace n equal to n, that is 1 divided by n minus 1 divided by n plus 1. Okay, here minus 1 plus 1 are cancelled. Okay, simplify to the term minus 1 by 2 plus 1 by 2 are cancelled, minus 1 by 3 plus 1 by 3 are cancelled, minus 1 by 4 plus 1 by 4 are cancelled. Finally, we get all the terms are cancelled. Finally, we get the term is limit n approaches infinity 1 minus 1 divided by n plus 1. Okay, 1 minus 1 divided by n plus 1. That is first term and last term remaining. Okay, using cross multiplication, that is limit n approaches infinity. Using cross multiplication means n plus 1 minus 1 divided by n plus 1. Okay, here plus 1 minus 1 are cancelled. Finally we get limit n approaches infinity n divided by n plus 1. Okay, here this is the rational function. Okay, this is the rational function. This is p of x, this is q of x. Okay, here degree of p of x is 1, degree of q of x is 1. Then the relation between p of x and q of x is equal. Degree of p of x equal to degree of q of x. What is the procedure for finding the limit of the given function is coefficient of highest degree of x in p of x, that is p of n. Okay, in terms of n means p of n. Highest degree of coefficient of highest degree of n in q of n, that is 1 divided by 1. That is the procedure is 1 divided by 1. That is limit equal to limit n approaches infinity. Here the coefficient of highest degree of n in p of n divided by coefficient of highest degree of n in q of n. This 1 equal to 1 divided by 1, which is equal to 1. LHS equal to RHS. LHS equal to RHS. Hence proved. Question number 10. A tank containing 5000 liters of pure water. Okay. Assume that this is one tank. Okay. This is one tank. Assume that this is one tank. Okay, tank have 5000 liters. Okay, 5000 liters, 1000 liters of pure water. Okay, pure water. Okay, of pure water. Okay, here drain very salty water that contains 30 grams of salt per liter. Okay, for example, this is 1 liter. Assume that this is 1 liter, 1 liter, 1 liter, 1 liter, totally tank containing 5000 liters. Each liter, this is 1 liter. Okay, 1 liter of water. Here 1 liter of water have containing 30 grams of salt. Okay, 1 liter 30 grams of salt. Okay, each liter have 30 grams of salt. Okay, 30 grams of salt contained. Okay, here salt per liter of water is pumped into the tank. Okay, pumped into the tank at a rate of 25 liter per minute. Okay, 25 pumped into the tank rate of 25 liter per minute. Okay, pumped into the tank 25 liter per minute. Okay, the concentration of salt water after t minutes. Okay, after t minutes in grams per liter is, this is the given function modified to c of t. Okay, which is equal to, that is concentration of time t. Okay, 30 t divided by 200 plus t. Okay, given c of t, which is equal to 30 t divided by 200 plus t. Okay, what happens to the concentration as t approaches infinity? That means the time approaches infinity means, as given t approaches infinity means, then c of t, then what value of c of t? Okay, to find what value of c of t. Okay, here apply limit, that is limit t approaches infinity c of t, okay, c of t, which is equal to here limit t approaches infinity, then the function is 30t divided by 200 plus t, okay. Here in terms of t, degree of p of t is 1, degree of q of t is 1, then the relation between degree of p of t and q of t is equal. What is the procedure to find the limit of the given function? Coefficient of highest degree of t in p of t divided by coefficient of highest degree of t in q of t, that is 30 divided by 1. Here 30 divided by 1, which is equal to 30, okay, which is equal to 30, okay. Thank you students.